little bit is kind of like the first bit of the last section. So you're just deciding if a certain ordered pair, guys, satisfies the solution set. So does it satisfy both of the inequalities? So if we have 0, 0, and we plug in 0, 0, we have 0 is greater than 2 times 0 minus 3, and we're seeing if that's true. So we have 0 is greater than negative 3. That is true. So when we check it in the other one, the x minus y is greater than negative 1. We have 0 minus 0 is greater than negative 1. 0 is greater than negative 1. That is also true. So what this means about the point 0, 0 is that it is in the shaded region for both of those. So it's in the overlapping shaded region, okay? So if we try 3, 1, we have 1 for y and we have 3 for x. So we get 1 is greater than 6 minus 3, which is 3. And that is false, right? 1 is not greater than 3. So that doesn't work. You could try it on the other one. And we would have 2 is greater than negative 1, which is true. So basically this one would only be in one of the shaded regions. It would not be in both. So, I mean, you don't have to draw this, but maybe you have 2 overlapping lines. We have the shaded region here. We have the shaded region here. And maybe that point is in one of those. Okay, but it's not in the final solution set for the whole system of inequalities. Does that make sense? All right, so it says to solve a system of inequalities, we graph each inequality and we find where they overlap. So we're going to do that. So it says graph the following systems of inequalities. So if we have y is less than x minus 5, we have a y-intercept of negative 5. So go down 1, 2, 3, 4, 5, and draw our point. And our slope is 1, so we're going to be going upwards. So up 1, right 1, up 1, right 1, and so on. Will this line be dotted or solid? Dotted, don't forget about that. And the other one's going to be a solid line. So when we sketch this one in, we're going to have our dotted line. And then we're going to decide which way we shade. So since this is already in the form y equals mx plus b, do you guys remember where we shade? Yeah, it's y is less than x minus 5, above or below? Below. Do you guys remember that trick? When it says less than, it's below. So for this one, we would be below our line. So use one of your colors. All right, now the other one is y is greater than or equal to negative 2x plus 3. So we're going to go up to the y-intercept of 3. Our slope is negative 2, so I go down 2, right 1, down 2, right 1, and so on. This time it's a solid line. And then when I decide where to shade, since it says y is greater than or equal to, is it above or below? It's above, right? So we're going to shade this way. So our final shaded region is just this little area right here. Okay, so you don't have to make it like super dark or anything. I'll be able to tell by the colors overlapping. And it was dotted along the edge there. Okay? Yeah, Eric?
Couldn't you just draw the lines first?
And then decide where the final one is? Yep. And when we have a lot of lines, so Eric's saying, can you just draw the lines and then decide where the shading is at the very end? When we have a lot of lines, that's what we're going to do. We're not going to do a whole bunch of shading. We'll just kind of think about where the final solution is. All right, so these ones are not solved for y. So we could do the x-intercept, y-intercept method for these, or we could solve them for y. It's not a big deal. Just remember when we divide or multiply by a negative number, we have to flip the inequality sign, right? So this first one, we would have y is less than negative x plus 1. We just subtract the x to the right side. So our y-intercept is 1, and our slope is negative 1. So I go down 1, right 1, down 1, right 1, down 1, right 1. Or you could go up 1, left 1. And it's a dotted line. And since I've solved for y, I can tell if it's going to be above or below. So since it says y is less than, right, we're going to be below. So we're going to be this way. All right, the next one, if I solve for y, is a little bit harder. So I'd have 2x minus y is greater than 2. Let's say I subtract my 2x over. So I have negative y is greater than negative 2x plus 2. But now when I divide by that negative 1, remember that's the red flag rule as I call it. We divide by a negative number. So we flip our inequality sign. So we have y is less than 2x minus 2. So we flipped. We had greater than before. We now have less than. Okay, don't forget to do that, because if you do forget it, then you're going to mess up your shading, right? You're going to shade on the opposite side. All right, so I have y is less than 2x minus 2. So my y-intercept is negative 2. And my slope is 2, so I go up 2, right 1, up 2, right 1, and so on. And this is also a dotted line. And since I've solved for y, I can decide where to shade. So do I shade above or below? Below, right? Y is less than, so I'm going to shade kind of on the right side of this line. So our final shaded region is in here. All right, does that make sense? Yeah, Eric?
Since the first line is already shaded below
Uh-huh.
the equation, the
Uh-huh.
original line, couldn't you just be able to tell, because that's the only
Uh-huh.
point
Yeah,
you
you can
have
just
on
shade that final region, yeah. You don't have to shade both of those areas. Yeah, so Eric's saying, like, could you just do, like, you knew this one was shaded below, and once you start doing the other one and you know it's below, can you just only do right here? That's fine. Yeah, if you want to do that, that's fine. All right, next up. Okay, this one's a little bit harder, right? So the first one I have y is less than or equal to negative x. Okay, so that's in the form y equals mx plus b. It just doesn't look like it. It's y is less than or equal to negative 1 over 1x plus 0, right? That shows us our slope and our y-intercept. So we start at 0, and then our slope is negative 1, so down 1, right 1, down 1, right 1, down 1, right 1, and so on. Or you could go up 1, left 1, up 1, left 1, up 1, left 1. And it's a solid line. And we have everything below it. So now notice how we have more than 2 lines. Okay, so this is where it starts to get a little bit tricky. So a lot of times when I have this, I kind of just draw like little arrows, and I'm like, okay, right now I'm below that line. Because once you get a whole bunch of shading, it's really hard to tell. All right, now the other one is y is greater than x, which is still y is greater than or equal to 1 over 1x plus 0, right? Same idea. So I have 0, 0, up 1, right 1, up 1, right 1, up 1, right 1. And that's going to be a dotted line. And will I be above or below that line? Above, right? Y is greater than. Okay, so we've created an X shape. So tell me right now where the shading is. Is it on the left, the right, the top, or the bottom of the X? It's on the left, right? Because we're above this other line. So the place where they would be overlapping is right in here. Okay, so you could shade just that area right now, or we can wait still. And then the last one is actually 2 inequalities in one. Do you guys remember in chapter 1 when we had absolute values? The first thing we would do is we would write, when we have absolute value of y is less than 3, we would say, okay, well, y is less than 3. We just drop the absolute values. Do you remember what the other one is going to be? Yeah. Y is greater than negative 3. So we flip the inequality sign and we make the number the opposite of what it was before. You guys all remember that? So we actually have 2 things that we're graphing. Okay, and if I have y equals equations are horizontal lines. So this is going to involve 2 horizontal lines. So the first one is going to be y is less than 3. So at y equals 3, I'm going to draw the boundary line. So I have this. And I'm going to have everything lower than that line. So I'm going to be below the line. So now think about where we are right now. So don't draw this in, but right now we're right here. Do you guys see that? Because we cut off that little triangular piece. You get it? And then the other one, let me use a new color. The other one is y is greater than negative 3. So if you're greater than negative 3, then at negative 3 we're going to do a dotted line. I thought I had green there. Maybe I didn't select it. I don't know. Oh well. And now I'm going to be above that line. Okay, can you tell what the little shaded final answer is? Yeah, so it's going to be right in here for the final one. Okay, so it's a little bit of a step up from Algebra 1. We're doing a lot more lines in Algebra 2. And 3.4 will be several lines, and then we're going to have some story problems with it. That's our final shaded region. All right, now this one says, find the coordinates of the vertices of the figure formed by the system. So sometimes you can tell what the corner points are. Like I think on this last one I can kind of tell, oh, it looks like a corner point's right here, it looks like a corner point's right here, and so on. That's what we're talking about, corner points. Sometimes you can't tell. So like on a lot of these ones, they looked pretty good. But sometimes it's really hard to tell where our corner points are. So what do you guys think we would do if we were trying to figure out where one line intersected another line? What could we do to find that besides graphing? If it looked like it was kind of between a space and we weren't sure. Nick, what do you think? You could plug in a point and check, right? If it was close to a certain point, you could say, oh, let me plug this in and see if it works. Okay, what's a way that's guaranteed to work? We just did it in the last section. Substitution or elimination. Do you guys understand what I'm saying? So that's what we were doing. We were finding where lines intersected. So that's what we're kind of leading towards. We're going to be doing in 3.4 story problems with inequalities. We're going to find the corner points using substitution and elimination. So it's putting it all together. Okay. So that's why I said the first three sections are pretty easy, and then the 3.4 is a little bit harder. All right, so let's try this one. So it says find the coordinates of the vertices of the figure formed by the system. So I'm going to start with this 2x minus y is greater than or equal to negative 1. Okay, so the first thing I know is it's a solid line. I'm going to go ahead and solve for y. So I'm going to subtract my 2x over. So I get negative y is greater than or equal to negative 2x minus 1. And when I continue to solve for y, I'm going to divide by negative 1. So that's our red flag rule, right? So we have to flip that sign. So we do y is less than or equal to 2x plus 1. So I'm going to have a y-intercept of 1. And I'm going to go up to right 1. Up to right 1. All right, and it's a solid line. I could also go down to left 1, just as long as in the end my line is going upwards as I read it like a book, left to right. Now, since we're asked to find the corner points, it's not a bad idea to kind of extend. You know how we did this with the graphing section? Extend our points all the way to fill the grid, right? And then use a ruler. Okay, where's our shading right now? Above or below? Below. And below is like really like kind of the right side of that. It's almost vertical, right? So it's kind of hard to say like what's below, right? But it'd be this way. So you can do a couple of arrows to kind of guide you. So we're on the right side of that line. So I'm going to do the other one in another color. So I have x plus y is less than or equal to 4. That one's pretty easy to get into the y equals form, right? So y is less than or equal to negative x plus 4. But remember, I could always have done the x-intercept, y-intercept method. So this one's an easy one to do x-intercept, y-intercept on. If I cover up the x, I get y equals 4. If I cover up the y, I get x equals 4. So I should have x-intercepts and y-intercepts at 4. So I'm going to start up at a height of 4. And I go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. See, that's why the x-intercept's at 4. And you can kind of extend your line along the grid. And it's a solid line. And we would be below that line. So right now we're below the line. So we have made an X shape again. Am I on the top, bottom, right, or left of the X? I think I'm in the bottom, right? Bottom, yep. All right, and then the last line. So I have x plus 4y is greater than or equal to 4. So this one looks like it would be a really good one to do x-intercept, y-intercept on. What would the x-intercept be? 4, which is actually on that point already. What's the y-intercept? 1, which is also on that other point there. And then we can sketch it in. So you could also count the slope here. You could say, oh, it goes down 1, right 4, so I'm going to go up 1, left 4 to get the next one. Like you could get other points if you need it. So let's go ahead and sketch it in. But the hard part about not solving for y is, you know, whatever the sign is, it says greater than or equal to. That doesn't mean that I'm above the line. We don't know, right? So that's when you would have to plug in a point. So when you plug in 0, 0, let's say, you get 0 is greater than or equal to 4, which is false. So we don't shade towards 0, 0. So previously we were in this, don't draw this, but we were in the bottom part of the x, and we're not including 0, 0. So we're going to shade above the red line. Do you see the little tiny region that's formed? What shape is it? A triangle, right? So we're going to have this little tiny triangular region. Okay, and then we're going to talk about its corner points. So I label them. I call them A, B, and C for my corner points. And it doesn't matter what order you put your A, B, and C. All right, so A, B, and C. Can you tell what they are this time? Yeah, I think you can, right? Because we were very careful drawing it in. A looks like the point 0, 1. Do you guys agree? 0, 1. B looks like the point 1, 3. Which you could check by plugging it into the blue line that I did, and you could plug it into the black line, and you would get that that's true. And then C looks like what point? 4, 0. So those are your 3 corner points. Okay. So we'll be doing that a lot in the next section. All right, is that the last one? Yep. All right. So we'll stop there.